Hey, folks. Welcome to our last night of the live streams. A little late getting started here by about 4 minutes, but had a little bit of technical issues on the back end. But this is our last live stream, or last two live streams of spring break. So let me see if we can get this set up. So for those of you just joining us, real quick, let me tell you what's going on. My name is Scott Ford. I am a teacher here out in Humble ISD, as well as an adjunct professor for Lone Star Community College. And I'm actually on spring break right now. But I've got students who are preparing to take their CompTIA A+ exam, as well as their CompTIA ITF Plus exams at the end of the semester. And so I'm doing a series of live streams for them so they can review this stuff as well, kind of making sure that they are well positioned to sit for their certification. So that's what we're doing here. That's the whole goal of these live streams. So for those of you who are my students in class, welcome. For those of you who are watching who are not students in my class, I'd like to welcome you as well. I do want to share something with you real fast, and that is our Discord QR code. That is the QR to get into our Discord channel. We got a bunch of students in there, college students, as well as folks from around the country who are also working on their certifications. You're more than welcome to join us. So with that being said, I actually want to hop into what we're covering today, which is kind of the fundamentals of networking. Now, this is geared towards ITF, but it does set the foundations for networking that you're going to need to know in A+, as well as networking that you're going to need to know in Network Plus. So this is kind of the entryway that we're going to cover the basics of networking. And then later on tonight, time permitting, hopefully, we will talk about wireless networking. So hi, Rio. Thanks for joining us as well. So I guess with that being said, let's hop into this and take a look. And by the way, just a little word of a little heads up. At least once in a night, the PowerPoint will crash on us. So I'm not completely sure why that's doing it, but it is what it is. So let's take a look at networking fundamentals. And our objectives for this unit are to explain the purpose of networking devices, identify and give the functions of typical network components, list and explain different types of networking classifications, give brief descriptions of server types, list and give the characteristics of types of networking media, list the 7 layers of the OSI model, and give a brief description of each. So let's jump into the basics of networking. So before we get going into this, what is a network? What is the purpose of networking? Well, a network is, and the New Penguin Dictionary of Computing defines it as any collection of entities connected together by some form of conduit to form a coherent group. Basically, a network at its most basic level is connecting devices together to share resources. Okay, that's the whole purpose, or that's what networking is we are connecting devices together. Now, back in the older days, those devices were pretty much servers and computers for the most part. I mean, there was other things there, but those were the big things that we connected. Well, nowadays, our networks can consist of our smartphones, our tablets, our televisions, our washing machines, all sorts of different things. So, but at the end of the day, they're all connecting together in order to share resources, to share functionality. So why do we network? Well, by connecting devices together, we can accomplish things that just one device couldn't do on its own. So it enhances the functions of that one device. So here are the reasons to network. First of all, we have sharing. You can share resources like files, data, media, processing power, applications. We have communication. So it allows us to communicate with others via email, instant messaging, conferencing, all sorts of fun things like that. We can do organization. If we do it correctly, we can centralize our data and information, hopefully making it easier to access and store data as well as do backups. Again, that's if it's actually done correctly. And speaking of if it's done correctly, if we do networks right and we do them smart, then we can also save money. By allowing us to share resources, we don't have to recreate everything. We don't have to have additional computers to do things that we might be able to centralize our servers in and access information. So ideally, if we have a network that's set up correctly, then we can save money through not having to buy certain things, as well as opportunity loss by having a more efficient workforce. And again, the caveat on that one is if we do this correctly. If we don't do it correctly, then you can lose productivity, you can lose all sorts of fun things. I won't get on my soapbox, but one of the places I work for, I'm going to get myself in trouble, so we're going to move on now. So, typical components in a network. So many of these components we are going to discuss in more detail as we progress through this unit, as well as the next unit and the following unit, although that's not going to make it into tonight's live stream. What we're looking at here is basically a vocabulary dump. Now, let me explain real fast. We are going to I hate to say basically over and over again, but what we're going to do right now is we are taking a look at the basic definitions, the fundamental definitions. The reason we're doing this, the reason why quit saying basic, the reason why we're doing a vocabulary dump is so you become familiar with the terms now. So as we discuss them later, you go, oh yeah, I heard you say this. It's more or less starting the brain to process this information. So by introducing the terms now, by getting these definitions out of the way, by doing this vocab dump, we are allowing your brain to start processing this. So as we go into them in more detail later on, it makes it easier to do. So there's actually a whole learning theory behind why we're doing this, okay? So just that's why we're doing this. First, we're going to take a look at a backbone. A backbone is typically a high-speed, high-capacity, long-distance network that connects smaller local networks together. A client is a device that connects to the network in order to use some resources or services. This client could be a smartphone, tablet, workstation, game console, whatever it is. You are basically asking for resources from the network. They are requesting stuff, and we will talk about a client-server relationship later on. We have firewalls. Firewalls could be a hardware firewall, a software firewall, or a combination of the two. And the purpose of a firewall is to enforce policies, security policies that we set up for an organization. These policies could be things like limiting access to resources, to keep out bad guys, to keep protected information within an organization from getting out accidentally or on purpose. Firewalls are a huge component when you learn about security, which is kind of cool. We have host. If the client requests resources or a service, the host is the device that answers that request. So client's request, and the host answers that question. It answers that request for resources. We have a hub. A hub is considered a dumb device. We will make more sense of hubs, switches, and routers later on when we talk about the OSI model. If you've never heard of the OSI model, you're going to have fun. It's a fun topic. Everybody in networking loves to talk about the OSI model. For those of you who are familiar with the OSI model right now are going, he lies. He sits on a bed of lies. Well, we'll cover OSI later on. But for now, realize that a hub is a dumb device. We'll explain it later. That will broadcast networking information to every device connected to it. We have intrusion detection system. That's an IDS. And this is designed to detect, log, and respond to unauthorized networks or host use. Think of this as a fire alarm. If your network is being attacked, how do you know it's being attacked? For example, if there's a fire somewhere, how do you know there's a fire? Well, hopefully a fire alarm goes off or you see the fire. And IDS is basically the fire alarm within the network that says, hey, we're being attacked. Then we have an IPS. This is an intrusion prevention system So while an IDS will, give me just 1 second, folks. While an IDS will let you know you're being attacked, an IPS is there to kind of fight that intrusion. So if the IDS is a fire alarm, an IPS is your sprinkler system. It's there to kind of fight back against the intrusion. We have media, the way data is transferred from one device to another, and media could be copper cables, fiber optic cables, could even be wireless. We have something called a NIC. A NIC stands for Network Interface Card. When I was taking Cisco many years ago, we had an English teacher who then became a Cisco teacher, and he drilled into our heads, you do not call these NIC cards. They are not NIC cards. They are NICs, because NIC stands for Network Interface Card. So if you call it a NIC card, you're saying it's a Network Interface card. So as you may or may not know, never mess with English teachers. So don't ever call it a NIC card. It's a NIC. And if somebody asks you why, just say because an English teacher said so. The NIC is a device that allows devices to connect to the network. We have something called a node. A node is any device connected to a network. It is a generic term for anything connected to a network. It's just a node. So if you don't know if it's a client, a host, or whatever, just call it a node. That's your safe term. We have something called a network operating system, or a NOS. A network operating system are special software designed to run on a network server. It's designed to handle the very specific and unique requirements of a network. Knowing how to work in a network operating system is in itself a career. So you can learn how to use Windows Server, you can use some sort of Linux server. This is a career on its own where you learn how to use this, and it can be a very well-paid career option. We have protocols. Protocol is an umbrella term that we use to describe the rules that devices use to communicate with other devices on the network. One of the big protocols that you will need to be aware of if you go into IT is the TCP IP protocols. It's an entire stack of different things that are underneath it. And when we talk about WAN and the wide area networks and the internet, we actually go into some of these protocols in more detail. For those of you in A+, you get to know them in much more detail. And if you go into Network Plus, you really get to know these. So just for now, know that protocols are rules of engagement. They are rules on how things are supposed to act. We have a proxy. A proxy will take a request from a client system and then forward that request on behalf of that client. We have different types of proxies that are out there. We have the anonymizing proxy, which will hide information about the device requesting the information. It makes a user's web browsing experience anonymous. Now that, to non-computer people, that sounds pretty shady. You know, why would you want to be anonymous if you're not doing anything wrong? You know, what should you be afraid of? Well, you know, I use a VPN. My business is my business. I'm a big component of privacy. And, you know, I used to work for government. I used to work for the U.S. intelligence community. And you want to talk about people who want the government out of their business is the intelligence community. So there's nothing inherently wrong or evil or shady about wanting to protect your privacy. So that's my little soapbox. Moving on. We have a caching proxy. Caching proxy keeps local copies of popular clients. This can help speed up the network because you don't have to continually go back online to get things that you typically use commonly. So let's say there's a web page you access quite a bit. You might not be seeing the most current version of it. You might just be seeing a cached version of it. We have a content filtering proxy. This is very common when we're working in organizations of any type. And basically what content filtering does is it content filters. So if you work in an organization, most organizations don't want employees browsing pornography or gambling while they're at work or watching violent videos. So a content filtering proxy is there to filter content. So that is what that's for. We have open proxies. These are available to any internet user. It has some ability to make you anonymous, can be used to circumvent corporate proxies. And web proxy, this handles web traffic and is sometimes called a web cache. Now, really fast, kind of a last argument for the need of these proxies that can help make you anonymous or bypass things. There are countries out there that are very kind of closed to their citizens, right? They don't want their citizens accessing news. They don't want their citizens accessing what's going on in the world. And so in some of these countries that are very locked down, sometimes the citizens' only way to get news from outside of the propaganda machine is by using proxies to get around what the government has locked down for them. So there we go. All right, let's talk about routers. A router is a smart device that will send network data to specific nodes on a network. So hubs were dumb, routers are smart, and we'll look at these in more detail as we go through. Then we have servers. I've already talked about servers a little bit already. This is a device specially designed to handle the sharing of resources on a network. These are typically the most expensive computers in an organization. They typically also require specialized training for folks to be able to use. Let me pull up a page for you. Let me see if I can pull this over here. There is a certification that CompTIA offers. Hopefully I'm not going to crash anything as I'm doing this. This is taking way too long for it to load. Come on. There it is. All right, let me pull up the certifications. There is a Server Plus certification from CompTIA. This is really taking a while. Honestly, my network is not this slow. I've got fiber coming into the house from Takis. I'm wondering if somebody else in my house is live streaming right now and eating up my bandwidth. There it is. There's the CompTIA Server Plus. So this is Server Plus. This is a special certification designed for folks who want to go into server administration. And it's not showing up. What? There we go. There it is. Okay, now I see it. So this is Server Plus. It is, like I said, a separate certification just for folks who want to know more about servers. All right, so moving on to switches. So if a hub was a dumb device and a router is a smart device, a switch is in the middle. It's not dumb, it's not incredibly smart, but it has some intelligence to it. I'm using the term intelligence very loosely here. We have something called a thin client. A thin client usually has little to no software installed on the device, uses applications on a network. Know what a thin client is. This might show up on the certification exam. Wink, wink, be aware of it. So a thin client usually has little to no software installed on the device. It uses applications on a network. So the applications are on the network itself that it is using. A workstation is your typical personal computer. So that was a definition dump. Not the best as far as ultimate teaching, but like I said, the purpose of this was to introduce these terms to you. So as we go through the rest of this presentation, as we go through the next live stream tonight on wireless, and if I continue to do live streams later on, when we take a look at the internet and the wide area networks, you at least have exposure to these terms. That's the whole purpose of this, okay? So let's talk about types of networks. We can classify networks on 3 criteria. We can classify networks based off of geographical location. We can classify them on topology, and we can classify them based off of how they share resources. For this particular section, we're going to take a look at how we classify them based off of geography. And you might have heard of these before if you've been in computers. If not, we're going to introduce them. But these are pretty standard ways to classify our networks. We have, and I'm not making this up, and these are legit. You have personal area networks called PANs, local area networks called LANs, campus area networks called CANs, metropolitan area networks called MANs, and wide area networks called WANs. So taking a look first at a personal area network. This is the smallest of all the networks. Examples of a PAN include, for example, your smartphone. Okay, your smartphone has Bluetooth. I have in my ear an earbud so I can hear some of the audio on the computer itself. Well, I have a smartphone, I've got a Fitbit, I've got a laptop, and I've got my earbud. I've created a PAN. All of these can be connected together through Bluetooth. Okay. When I was originally teaching this, explaining what a PAN was back in 2004, 2008 was kind of hard to explain. It was a lot more conceptual. But now, I mean, I teach high school. Kids are walking around with PANs all the time. They're walking around with their smartphones connected to their headphones, connected to their smartwatches. They have their own personal area network. So we don't have to conceptualize it anymore. We see it all around us. So that is what a PAN is, a personal area network. Then we have a local area network. A local area network, components of the network are within a local region. Typically, the components are found within the same building or same floor. So examples of this might include the devices connected in a house, an office, or a building. So local area networks or LANs. Typically, a LAN will consist of at least two devices with network adapters, some type of media to connect the devices so they can network together. This could be cable or wireless. Usually you have a central device that connects the devices together, and there is a numbering scheme so the devices can identify each other. You probably have this wherever you are right now. If you're watching this video at home, you probably have a LAN right there. You're probably watching this on your phone or on a tablet or a laptop or a computer or maybe a smart television. All of these are probably connected to a wireless network of some type. If you have a home router, a wireless router, that would be your central device that connects everything together. So this is a great example of a local area network. These have become a lot more common than they used to be in the old days, back in Windows 95, 98, where we had dial-up connections. Then we have something called a campus area network. You typically find these on a college or university campus, and it's LANs that are connected across the campus at a college, university, or business park. So what we see here is actually, there was a picture of Texas A&M, go Aggies, I have my master's from there. And if you go on a college campus, whether it's A&M, Lone Star College, I believe even TU has figured out how to put networks together. UH, I'm not going to say anything bad about U of H. My wife is a graduate from University of Houston, so they're great. Sam Houston, whatever, you are part of their network. They usually have some sort of name for it. Maroon or Go Cougs or whatever. But that's a campus. That's a campus for that college. Also, some companies are very big and they have campuses. So for example, Apple has massive facilities. They're all on a campus. Microsoft has campuses. These big companies have campuses that take up quite a bit of room. And so these are also known as campus area networks. We have something called a metropolitan area network. These are bigger than CANs, smaller than LANs, and this connects LANs across a city. So for example, I was in San Antonio, this is pre-COVID, for about 2.5 months doing training for CompTIA. I did training for ITF Plus, A Plus, Net Plus, Security Plus, the whole course series for a bunch of students. And San Antonio, Texas, has a metropolitan area network, has a MAN, where if you're in any government, San Antonio government facility, whether you're in town hall, we were teaching out of the Cafe College, which is part of San Antonio City, the libraries. If you're in a building owned by the city, you have access to their MAN, their metropolitan area network. MANs can also include things like access to the fire stations and the police stations. They're all kind of connected on the back end, at least some places are, and that forms a MAN. Then we have something called a WAN, or Wide Area Network. This is the largest of the networks. This network connects lots of separate LANs across large distances. Probably the most well-known example of a WAN includes the internet. But here's the thing, the internet is not the only example of a WAN, a wide area network. In fact, militaries, especially the US military that has bases all around the world, it makes up their own WAN. You might have large multinational companies that also have their own WANs that spread across the globe. So WANs are wide area networks. So those are the classifications of networks based off of geography. Now let's take a look at networks based off of topology. And topology describes either the physical layout of the network or the logical layout of the network. So let me explain what these two mean. A physical layout of the network is how the devices are physically laid out. Does it have a central device? How are the devices connected to that central device? How are the devices connected to each other, if they're connected to each other at all? So physical layout is the physical, what it looks like, generally. Then we have a logical topology. Logical topology has to deal with how signals are sent, how signals are received. So physical topology is the layout, while logical topology is how the network communicates with the network. The physical topology includes examples like bus, ring, star, and hybrid, while a logical topology consists of Ethernet, which is the big one, as well as ring. The old topology. This is an old topology. This is a bus topology. What you're seeing here is this line down here. This represents the backbone cable. And from this backbone cable, you've got these different nodes that are attached. Now, in the A+ exam, it used to be, it's not as big anymore, but in the Network Plus exam, you would have to know about how we attached devices to this. We had VIA power connectors and all sorts of other things, and there was a certain amount of space you had to do between connections, but this was a bus topology. It had a single cable, the backbone or trunk, that connected all the devices together. And all the devices attached were called networking segments. Only one device can communicate at a time. Let me back up here. One of the problems with a bus topology is if one device died, if one device went down, the entire network went down with it. Now, that wasn't too much of a problem if you had two devices on a bus topology. But if you have, let's say, 10 devices on a bus topology and one goes down or there's a break in the cable, you now have to find where that break is or where the down computer is. This is like trying to fix old-time Christmas lights. Back in the old days, if your one light went out on a Christmas light and a whole strand, you had to replace every bulb to find out which one was burnt out or where the problem was. So that is a ring topology. Or excuse me, that was a bus. That's my bad. Bad, Mr. Ford. That was a bus topology. Now we're going to talk about a ring topology. A ring topology, all computers attach to a central ring of cable. There is no beginning or end. It is a closed loop. It can be a single ring or dual ring if you want to add additional fault tolerance. So a single ring, one cable connects all the nodes, while a dual ring has two rings and data can be sent in both directions. It also added fault tolerance because if one of the rings had a problem, it could still communicate. Then we have the star topology. The star topology is the most commonly used physical topology. Devices on the network connect to a central wiring point. In the early days of networking, the central point was typically a hub. Now, for most home offices and small offices, or SOHO, small office, home office, we use a router. Now, I will say, let me back up just one. Let me add this. If you go into this in more detail, you're going to find that there's a little bit more information as far as the physical topologies go. And they're right. But we are introducing the basics. You have to know the fundamentals before you can get to the more advanced stuff. And for the ITF Plus certification, they don't really want you to know the more advanced stuff. They want you to have these fundamentals down. So that's what we're focusing on here. But if you're using these videos to study for A+, and especially Network Plus, you're going to need to know these in a little bit more detail than what we're covering here. But this is a great starting point if you're new to networking. Let's talk about a mesh topology. A mesh topology is incredibly fault tolerant. You have multiple pathways to devices. One primary or one pathway goes down. You have more to choose from. Mesh topologies are incredibly fault tolerant because you have so many connections to the different devices. And we really have two types of meshes. We have a partially meshed network. Minimum of 2 devices have redundant connections. This is the more popular of the meshes. While we have a full mesh, and as you can see, every device is directly connected to every other device. And this is not a very practical method of connecting these computers, but it is insanely fault tolerant and almost impossible to take these networks down. But as you can imagine, they are incredibly complicated to set up, and they can get very expensive very quickly because every computer has to be connected to every other computer. Every device has to be connected to every other device. All right, that was the physical topology. Now let's talk about logical topologies. The first one and the most popular is the Ethernet physical topology. This is what you typically encounter in networks. This is kind of how logical topologies work. I'm introducing the other one because we have to talk about it, but Ethernet is pretty much the king. This is what you're, I would say, 99.99% going to run into. The other one is called the ring topology. And like I just said, Ethernet is king. You probably won't run into a ring topology, but if you do, traditionally used a ring physical topology. It sent signals from device to device and made its way around the network. Now, I will say this. When I was first studying for the certification exams, ring topology, you might also hear token ring topology. And I remember seeing a test question where it asked, what and I saw token ring. And I thought, are they talking about tokens ring? My precious? No, it has nothing to do with Lord of the Rings. What a token ring is that it's like the talking stick. You can't talk unless you have the talking stick or the talking shell or whatever some new age guru's going to tell you to use. And what happens is a computer has the token. It can send a signal if it wants. If it's not going to talk, it sends the token to somebody else, and then they can talk, and so forth and so on. So, but again, token ring topology, as far as physical goes, is not very common. You don't run into it. I hate to say you'll never run into a ring topology, but the minute I say that, somebody's going to pop in and says, no. We use ring topology, logical topology here in my office in Death Valley. And then it's like, well, all right, now I got to change that. So moving on to Ethernet, which is the most common, most popular type of logical topologies. So Ethernet uses a standard known as IEEE 802. IEEE stands for Institute for Electrical and Electronics Engineers. It's not too important you know what it stands for as far as what the letters are, but it is important that you know that this is a standard, right? These are folks who come up with standards. And the 802 standard defines various types of logical LAN networks. And under the 802 standard, and if you go into this IT world anymore, you're going to hear 802 quite a lot. Under the 802 standard, there are several other standards. The two that we're most interested in is the 802.3, which is the Ethernet standard, and the 802.11, which is the wireless networks, which we'll talk about in the next live stream. So 802.11 is wireless networks, while 802.3 is the Ethernet. Little fun trivia for you. The 802 standard was developed back in February of 1980. So the 80 portion of 802 stands for the year it was developed, while the 2 stands for the month. So just kind of a fun little trivia for you. So looking at the 802.3 standard, this is the most popular LAN technology. Ethernet defines the speed, types of signaling, and physical medium that can be used for the network. And there are, for those of you who watched the live stream on Command Line, I pulled out a book that was about this thick. I don't think I've got, I don't think I have it out anywhere. What I'm looking for right now on my bookshelf is, I had a book, I'm not sure where it is. It was just on Ethernet standards. It was just on the 802.3 standard. This thing was an O'Reilly book, of course, it was O'Reilly. And this thing was thick. And it just talked about the Ethernet standard. So you can study Ethernet. It's not just a little, oh, by the way, there's a whole bunch of documentation you can do on Ethernet. So 802.3. Anyways, I digress. We have something called the CSMA CD. And this stands for Carrier Sense Multiple Access Collision Detection. Now, I'm going to read the verbiage to you, and then I'm going to explain it in more detail, or make it make sense, okay? This is how Ethernet handles communication along the network. Only one frame, this is how data is packaged on the network, you send frames, can be sent at a time. If another frame is sent while a frame is already on the network, they crash into each other, and the frame data is destroyed. Okay, so what did I just say? If you've ever had the chance of using a land phone, right, the old-fashioned phone that you would have around the house, and you would pick up the phone and you would listen for a dial tone. Now, I say old-fashioned because even at my house, we don't have a land phone. We all have cell phones. But in the old days, you would have your land phone, and you would pick up the phone and you would listen for a dial tone. If you heard the dial tone, that meant that it was ready for you to call out. You detected that it was ready to make a call. Okay? You have the carrier sense. You know that the phone is alive. You know that you can make a phone call on it. But if you picked up the phone and you heard people talking, if you heard a conversation already on the phone, then you put your hand over the thing and just listen in. I'm kidding. No, you'd hang up, okay? Because the phone line was busy. Well, that's what Ethernet does. Ethernet picks up the phone, listens in on the network cable, and goes, is anybody talking? Is anybody talking? No? Okay, I can send a signal. And then it sends a signal out. Now, back to our phone analogy. Let's pretend that you pick up the phone, you hear the dial tone, and you start dialing the phone. But then somebody else picks up the phone and they start dialing too. Well, this is the collision detection. Now we know that there are two people or more trying to communicate at the same time. And at that point, you both kind of have to get off the phone line and then figure out who's going to make the phone call. Okay? Well, in Ethernet, what it's going to do is the network card's going to go click it on, listen in. If it hears the tone, if it hears the dial tone, if it picks up that the network can send, you can send the signal, it's then going to send its information. It's going to send its frame out. If another computer on that same area, and I'm not using the technical terms for this intentionally, but another computer on that same network then sends its signal, they're able to pick up the fact that they crashed into each other. That frame of data has been destroyed. And then what happens is that they both back off. they pull a random number, and then they'll try to send their signal again. Now, this works great until you have a whole lot of computers on the same kind of phone line. When you have a bunch of computers on the same phone line, then what winds up happening is you get a lot of ones that want to send their information at the same time. You have a lot of what we call collisions. We have a lot of lost signals, and the network starts to slow down significantly. Many years ago, this was actually before I got my A+ certification, I taught at a private school. And this was still when hubs were kind of the main device in the middle. It was the star network, and the hubs were in the middle. And they all keep the same domain. They all keep the same broadcast area. And we had a whole bunch of computers attached to it. And whenever the students would go to the library, they would have, everything would slow down because everybody's trying to access things all at once, and the signals would keep crashing into each other, the frames would crash into each other, and slow things down, okay? Now, the wireless devices use a variation of this. So they use carrier sense multiple access, but they use collision avoidance, which is something we will take a look at much later. Now, I have oversimplified Ethernet intentionally. This is the ITF Plus certification. So I have purposely kind of made this a little bit easier than normally one would run into. And what you can't see on the back end right now is that the PowerPoint went and died. So I am relaunching PowerPoint. I think someday I'm going to try to figure out why this does this. So let me get back to where we were a second ago. There doesn't seem to be any rhyme or reason for when this happens. It just does it. This computer is not a weak computer. Actually, this computer's got some pretty good specs on it. All right. So let's go back to our conversation. So we took a look at our topology. Now we're going to take a look at resources. How does a network share resources? So there are two ways that we need to look at as far as sharing resources. There is the client-server method, and there is peer-to-peer. A client-server, machines known as the host, which we talked about the definition not that long ago, and you have servers provide resources for other devices. Now, let me break this down because this really isn't that complicated. If you ever go to a restaurant, okay? For example, you go to Waffle House. For those of you that know me, you know I am obsessed with Waffle Houses. But for those of you who don't know me, guess what? I'm obsessed with Waffle Houses. So you go to Waffle House, okay? You go into the door, you step over, the people that are fighting on the ground, and you go to your booth. Over to your booth comes a server, okay? Comes the person who wants to take your order. In this situation, you are the customer or you are the client. You want your all-star special, okay? And you want your cup of coffee. So you sit down, you're the customer, you're the client. The server comes over to you, takes your order. I want this, I want this, I want this. The server then goes over to the chefs, puts your order in, right? They get your food, they bring you your food. This is a client-server relationship. You are the client, you request that the server brings you something, and the server provides you the resources that you want. So the machines known as the host or server provides resources for other devices. The other devices known as clients or workstations request these services. We have a special operating system. I talked about this in the vocabulary portion, where you have special operating systems called network operating systems or NOSes, and you have Windows Server. You also have Unix and Linux. These act as all network operating systems, and again, there is career fields just in being able to manage these types of environments. We have a few types of servers to be aware of. We have application servers. These run specific types of applications. So for example, at school, right, during the school day, I have to take attendance. I have to enter in passes because we got this e-hall pass. I have to do grades. These would be application servers. I'm accessing an application, not on my own computer, but on a server. Okay. Then we have computer telephony integration servers. What we're seeing is we're seeing a convergence of our computer networks and our phone networks. So for example, maybe you work in a building where you have Cisco phones that are attached to your network, which is also the same network that you attach your computer to. So for example, where I work during the day as a teacher, I have a network cable going into my phone, and I believe that network cable goes from my phone then to my computer. So we have this convergence of telephones and our computer systems. So these are servers that handle this. Now, I will say this, the bad guys have discovered that a lot of companies are moving towards computers and phones that are attached to the same network, and this is also a place that they can attack. So our phones are no longer as safe as they used to be. We have database servers. This is a central location that provides database services to other computers. We had a live stream just on databases not long ago. We have file servers. File servers are a central location that will store files. So instead of storing them on our individual computer, we can store them to file servers. We have messaging servers. Used to be just email servers. Now it's used for all types of communication. So not only do messenger servers handle our email, but they can also maybe handle instant messaging and things like that. Now, I will say this. Several examples I gave you are examples of that kind of a feel, for example, messaging services. But a lot of these things have now been replaced by, and we'll talk about virtualization and cloud computing in another unit, but software as a service. So for example, our school district and many school districts uses Google, right? Google's taken over our school districts. And we have Google Chat. So you can chat through Google. Now that's not being hosted really, I don't believe it's being hosted unless they got some weird setup, but it's not really being hosted on our own campus. We don't have a Google server. We are using Google's information. A company I used to work at, we were an office company. So we used Microsoft Office, and we had our SharePoint and all this other stuff. Teams, those aren't being managed on our own servers. Those are on the cloud somewhere. Okay, so just kind of a disclaimer there on some of this. We have network controllers, manages user accounts, computer accounts, network time, and general well-being of the domain. We have print servers. This handles what you would expect, which is print. And we have web servers. This serves up website content. All right, I'm going to take a quick sip, by the way. Coffee today, of course. I got my little mug. Let me see if I can see. There you go. That's from Hocus Pocus. And it's not the morning. In fact, it's 6:52 Central Standard Time. Again, Bones Coffee, not a sponsor of the program, but definitely powers up the program. And client servers. So what's good about client servers? The good part is you have central location to control user accounts and privileges. Manage share resources in one location. Easier to locate problems on the network. And servers are optimized to handle increased demands. They are specially built to do this. Of course, if there's good, there's got to be some bad. So what's the bad part about client servers? Well, can be a single point of failure. If the server goes down, so does the entire network. Servers can be expensive. These are typically the most expensive components in your industry, or excuse me, in your IT infrastructure. And servers require specialized trained individuals. Specialized trained individuals cost money, as well they should, because they go through specialized training to be experts in this type of world. The other type of sharing is peer-to-peer. This is the other type of resource sharing, peer-to-peer. Each machine acts like the client or the server at any given time, and they're all equal. So now this is not peer-to-peer file sharing. That's not what we're talking about here. We're talking about computers that are peer-to-peer on a network. This is where peer-to-peer came from. But on our conversation, this is like your laptop's connected to somebody else's laptops, and you're sharing and hosting resources. Peer-to-peer used to be extremely common long ago. Nowadays, setting up a peer-to-peer network at work is really a pain in the neck, because of wireless, and networks are so much more common and easier to set up. In fact, when you used to set up a wireless network on a computer, I want to say this was back in Windows XP and Windows 7 days, you could set up a wireless network that was a peer-to-peer network. And it was the default way to do this. It was the easier way to do it. Now, you have to do special configuration because your wireless card, your wireless network wants to automatically connect to a central device somewhere. So peer-to-peer is, it's still there. Obviously, you can still share peer-to-peer, but, there's better ways to connect devices versus this. So there's good things about peer-to-peer. One, it's cheap, right? You don't need any special equipment to it. It's easy to set up, a lot easier than, for example, a client server if you're setting it up through servers and all this other stuff versus a central location. No special operating system required. You don't have to put a server operating system on anything. And there's no special equipment past the normal hardware requirements for networking. Of course, there's bad things. For example, if you have a network of 10 or more computers, you do not want to do peer-to-peer. The 10 number comes from Microsoft. Okay, Microsoft even tells you anything over 10 computers, you shouldn't be doing the peer-to-peer with it. Peer-to-peer at best should be a temporary connection. Okay, but Microsoft themselves say 10 plus, not a good idea. Things get complicated very quickly and it becomes an absolute chaotic mess. Network problems can be harder to track down. You can't trace things back to a central location. Nope, not flexible for growth. Now, what I mean by that, because you'd think peer-to-peer would be easy to grow with. If you have, let's say, 5 computers and you set up the peer-to-peer connection, you've had to adjust sharing and permissions for all the computers that are attached to it. Every single computer, not just one computer, but all 5 computers have to be set up in order to share resources and connect to that peer-to-peer. Means the technician or whoever has to set up all 5 computers. Let's say you add a 6th computer to the mix. Now, it's not just configuring this new computer. It's not just configuring the 6th computer to play well. You've also got to configure the other 5 to work now with the 6th computer. Oh, you want to do 7 computers? Well, guess what? You're now configuring 7 computers to work with that brand new computer. So you can see as the peer-to-peer gets bigger and bigger, you now have to configure every computer all over again to accept anything new that you put in there. Versus a client server, which somewhere in a central location, you go turn that on, turn this on, boom, 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 you're done, you're good, and you're finished, okay? And finally, it's very hard to secure resources. Every computer must configure their own security and their own permissions as far as what resources can be used by other folks. You don't have one central location keeping track of it. Every device is responsible for its own security as far as resources go. Okay, so that was how we share resources. Now let's talk about types of media. So we have wired and wireless networks. To make a wired network, you need media to connect the devices together. In wireless, you need media to connect the devices together, but there's no physical wires. And we'll talk about wireless in the next unit. So a wired network, you have 3 basic choices as far as your media. You have coaxial cable, you have twisted pair cable, and you have fiber optics cable. The coax, you might hear 10 base 5. Oh, there we go. System failure. Telling you what, PowerPoint, you're not making me a fan. I really like PowerPoint. I don't know why this thing is crashing like it is. It's got to be something with what we're running here, because I can use this all day long and not have any trouble at all. But the minute I do OBS and I'm doing a live stream, of course it crashes. So moving on. All right, so types of media. Let me go to the next one. We have coaxial cable. Okay, this is what we connected our TVs with. In fact, you probably still run into coax quite a bit. Okay, the cable companies are still using coaxial cable. There's a lot of networks, internet network that still use coaxial cable. Okay, so this stuff is still here, it's still around. So when you think of coax, think of the cable that connects to your TV or your cable box. Then we have twisted pair cable. This is the most common type of cabling we see in local area networks. It's a bunch of wires twisted together within a plastic sleeve. We have copper cores used to send electrical signals. So remember that we have copper. In fact, we have copper in the previous one too. So in our coaxial cable, we've got a copper core. That is where the electrical signals are sent. So it's sending electrical signals. It's electricity running through this thing, okay? Pulses, zeros and ones, zeros and ones, zeros and ones. Copper wires are twisted around each other along the length to prevent interference. We're not going to get into the physics of why. Just know that they are twisted for a reason to reduce the interference that's happening along that cable. And we have two pairs of twisted pair cabling. We have shielded and unshielded. Shielded twisted pair cable has shields around the cables. It has this metallic covering around the twisted pair, which helps shield it. This is good to make sure you don't get interference. So in some environments, for example, you might have more EMI, electromagnetic interference, than others. And so shielded twisted pair cable helps reduce that interference. But there's a problem with this. It is expensive, okay? Because we've added a different component to our twisted pair cabling. The cabling that we're more likely to run into, because it's a lot cheaper, is unshielded twisted pair cabling. In fact, you can go to Lowe's or Home Depot or any other technology store and most likely buy a box of unshielded twisted pair cable, okay? Twisted pairs of wires surrounded by a plastic jacket. It's cheap and easy to use. If you are going to go into networking, I highly suggest going to Micro Center, going on Amazon or whoever, and buying a box of unshielded twisted pair cable. You can also get crimpers and you get your RJ45s. Those are your connections on there, and practice making cables. Again, that's a more advanced concept, not something for ITF. We have unshielded twisted pair cables that have different categories. These are called CATs, and CATs are rated in megahertz, and the higher the megahertz, the higher the CAT, the faster the transfer speed that the unshielded twisted pair cable can handle. So in this image, you see this is a 5E, it's CAT 5E. I just said RJ45s a second ago. RJ45s are the connection types that you use to plug into our NICs. RJ stands for registered jack, not important. A technician uses a crimper to crimp the RJ45 connections to the wires. This is put in here because this showed up on an exam, which is you have RJ45s. These are big connections. There is another type of connection called an RJ11. This is for our old-fashioned phones. This was our old phone connections. So the RJ45 is for our unshielded twisted pair cable, while our RJ11 is used for traditional telephone connections and modems, and it's smaller than the RJ45 connection. In the old days of computing, we would have modems built into our computers. Actually, in the old days, you had to buy a modem, put it in. But as they became integrated, they would be built into the computers. Well, nowadays, as wireless networks and wired networks have become more popular, RJ11 connections on computers, if you want one, you're going to probably have to go out and buy an expansion card and plug it in to have an RJ11 connection. And I will even say this, I've seen laptops that don't even have RJ45 connections anymore. They're assuming you're going to be on wireless. All right, so that was unshielded twisted pair cable and shielded twisted pair cable. Now let's talk about fiber optic cable. Fiber optic cable, unlike copper-based media, fiber optic does not use electricity to send signals. Fiber optic uses glass or plastic to send light. Now, this stuff is the most expensive of the types of cabling, although the prices come down, and we're seeing a lot more use of fiber optics. In fact, here in Casa de Ford, we were very happy when we were able to get fiber optics into the house. We have like a gigabit Ethernet, which is amazing. It's awesome. And it's fiber to the house. In fact, I've got fiber not only to the house, I have fiber coming into the house, into the the modem that TACAS has given us to use. So fiber optics is fantastic. It's insanely fast compared to everything else. And it's also insanely secured compared to everything else. To tap into a copper-based media like coax or twisted pair cabling is relatively easy. It's relatively easy to tap in there and intercept signals. Fiber optic, not so much, which is why I can tell you in secured environments where you have secret stuff going on, you're going to use fiber optics because you can't tap into it as well. You can't steal the secrets as well, and it's a much more secured connection. Additionally, because it uses light impulses and not electricity, fiber optics is also good for places that might be toxic or have explosive chemicals or explosive gases floating around. This used to show up on an A+ test question. Don't think it's showing up too much anymore, but if you were in an environment where you had to be very careful about open flames or sparks, you wanted to avoid copper-based media because it's sending electricity. Instead, you would use fiber optics as your choice. Fiber optics, of course, make great backbones for LANs and WANs because you can stretch this thing insanely long distances. And like I just said, great for places where security is a concern. Okay. Now comes the OSI model. I'm drinking some coffee. If you haven't got any coffee, you might want to go grab some. We've been lecturing now for an hour. If you're watching this on record, I would suggest pausing it, taking a little break before coming back because this is an entire concept. Now, we're going to introduce the OSI model. If you go into more networking classes, you get to some more detail. It goes into much more depth, okay? But the OSI model forms the foundation of a lot of conversations when it comes to networking, okay? So, and let me offer you this. At one point in time, the OSI model was new to me. All networking people, all IT people, at one point in time, it was new to us. And all of us went, how bad do I really want to go into IT? Okay. But we did it. We got over it. And so can you. All right. So here we go. OSI model. In the early days, when networking was still brand new, we had a lot of proprietary technologies. Everybody had their own thing. If you bought from a vendor, you had to buy everything from a vendor. It was all that vendor stuff. And the problem is if you had to repair anything or upgrade, it got expensive because you had to go back through that vendor. Or worse, let's say the vendor goes out of business. Well, now you're out of luck because you can't do upgrades, you can't repair, all that stuff is theirs. So what wound up happening is the International Organization for Standardization, or ISO, started looking at standardizing networking technology. And they created something called the OSI, the Open System Interconnect Reference Model. Don't worry what it stands for, just know it's the OSI model. And over years, they've added additional protocols to the OSI model. So why was the model created? It was created to help explain network communication between hosts on a LAN or WAN. It helped us create a categorized system for communicating protocol suites. It showed how different protocol suites can communicate with each other. Give me 1 second, a little technical difficulties on my end. Okay, so more or less, what we're talking about here is OSI was created to help us visualize how networks should work. Now, there's other models out there as well, but we all kind of start with the OSI model. And it's a model. What we're talking about here is, for example, let's just talk about our basic computers for a second, our basic desktop computers. You can go buy a computer from Dell, from HP. You can make a computer on your own, okay? They conform to standards. You can go and buy a keyboard from any other manufacturer, and you know that keyboard will work with your computer, right? It conforms to standards. It's a keyboard. But just because the keyboard might be from a different manufacturer, you know it's going to work with your computer. Same thing with monitors, right? If you buy a monitor from Samsung or Sony or Logitech or whoever's making, who do I have? HP. I got an HP monitor. It's a really nice one too. You know, even got an LG over here. you know they're going to work because they conform to standards. They know that the internal components of that monitor are proprietary. The internal components of a keyboard are proprietary. But for them to be able to function, they have to conform to standards so that they can communicate with everything else. So that's what we're talking about with an OSI model. They standardize where they're supposed to be in the model, but you can still have proprietary stuff inside. But you can buy a network interface card from any manufacturer and know that it's going to work with the media that it was designed to work with. Okay, so unshielded twisted pair cable is unshielded twisted pair cable. It's going to work with the network interface card that you have. You don't have to buy the same brand. You can buy any network interface card you want. You put it in your computer as long as it fits in your expansion card. It's going to work with that computer. It's going to work with the applications that are on the network. So the OSI model kind of gives us a commonality where we all agree to some common rules, although we can still be independent in some ways and make our own ways to do things. But at the end point, they all have to communicate both up and down the model, okay? So here we go. The layers in order: physical, data link, network, transport, session, presentation, and application. There are different mnemonics that you can use to memorize this. Mnemonics are ways to remember things. So if you've ever taken music, you might know of Every Good Boy Deserves Fudge, EGBDF, or FACE, FACE, right? The lines in the the treble clef, right? Or the spaces. This is ways to remember things. So we have mnemonics to help us memorize these in order. And you might see, please do not throw sausage pizzas away, or a few dead Ninja Turtles stink pretty awful. You can go the opposite way from 7 to 1. All people seem to need data processing. It is up to you which way you want to memorize these, as long as you have them in order. Now, you're not going to be asked on the ITF exam to write these out. I don't believe you're even asked to put them in order. But as long as we're talking about networking, you might as well start learning it now, because eventually, I believe in the Network Plus, you will have to put these in order. Okay, although I haven't looked at the Network Plus lately, so at one point they did. In fact, there's a new exam. I really haven't taken a look at the new exam yet. So in the old days, you had to know them in order. Okay, so you might as well memorize them. So let's take a quick look at the layers. We have the physical layer. This defines the medium that we're going to use to send signals. So are we using coax cable? Are we using fiber optic cable? Are we using twisted pair cable? Are we using wireless? This is the physical media that we're using to send signals. And we have a unit of measurement of this, and that is bits. Then we have the data link. The data link physical addressing is how transfer is done over the physical layer. So this is the stuff putting the information onto the physical layer, okay? Unit of measurement is in frames. That is the basic unit when we're talking about networking. That's the basic unit of signals that go out on your network, is the frames. Then we have the networking layer. The networking layer is going to find the best path from point A to point B, and this is measured in packets. Now let me explain networking. Networking layer is easy to understand. Okay. I have on my phone, I've got an amazing program called Waze. Love Waze. And what Waze does is I can put an address in, and I can say I want to go here. And Waze not only just finds me the location and says here's the direction. What it does is it may take me more miles to get there, but it's finding me the path of least resistance. It's finding me the path with the least amount of traffic or construction. It's going to get me there the fastest way possible. And that is what networking layer does. The networking layer is there to find you the best path to get to your destination. Pretty cool stuff. Then we have the transport layer. The transport layer is end-to-end connection and reliability. We have both connection-oriented and connection-less. So for example, TCP is like your mom who wants you to call when you get there. UDP is like, if you get there, you get there. If you don't, oh well. didn't love you anyways. So that's the transport layer. Then we have the session layer. This establishes and terminates, synchronizes communication. What I do with the session layer when I have students in the class is I go up to them and I shake their hands and we do introductions, right? So I say, hi, my name is Scott Ford. We shake their hands. They tell me their name. That is a session. We start and end the communication. That's what that part is. I also show them when a session doesn't work well, because then I go and introduce myself. I shake their hand. The minute they start to introduce themselves, I break off and I walk away. Okay? That is when sessions go wrong. So a session layer establishes that communication. It does, hello, my name is, nice to meet you. See you later, end communication. That's what a session layer is responsible for. Then we have presentation layer. This is how data is represented. Two things to be aware of in the presentation layer is encryption and decryption. And finally, application layer is the underlying protocols that support our network applications. These are not the applications themselves. So this isn't web browsing. This is the protocols that enable browsing to work. So let's go into these in a little more detail. And some of this I already told you about, but this is to, again, help you understand the OSI model. Layer 1, the physical layer. Networking standards for electrical signals, connections, media types. This is the stuff that you can touch, well, except for wireless, but this is how the signals are actually sent, okay? This is your network interface card. This is your cabling. This is all this other stuff. Now, I say network interface card, I'm not being, there's more to it than just that, okay? But the physical device that you plug in, the RJ45 device that you plug in to your network interface card, this is what we're looking at here, okay? So examples include signals, hubs, cables, connectors, and physical topologies. Now, I've got this, and we're going to see if this works. Let me try to see what we got here. We're going to see what our speed is. So I have this open. Let me make this bigger. Make this bigger for you guys so you can see it. All right. So I'm going to do an internet speed test because we want to see how fast our signals are. So let's go and we'll do, we'll do this and we'll see what happens here. And go. And hopefully I don't just completely kill my live stream. What we're seeing here is the speed of the network. We're seeing our download speed and we're seeing our upload speed. While that's doing that, I'm going to snag some coffee here. So up here, I can see my download speed is megabits per second. Remember, bits is a 0 or a 1, not bytes, but bits per second. So I can see my download speed, go away, is 720.79 megabits per second, while my upload speed is 660.96. That's not too bad. I can live with that. Okay. So that is how fast we are going. So we can see how fast the cable or how fast the speeds are going. Now I'm going to share with you some sites that I like or that you can check out. These are, or these focus, I should say, on buying cables. You can, of course, buy cables because we're talking about, layer 1. You can buy cables from Best Buy, which, it'll work in a pinch. You also have Newegg. I love Newegg. Newegg is a cool site. Love me some Newegg. Very dangerous site for me because I can spend a lot of money. But I want to introduce you to this site. This is called Monoprice. Monoprice, I discovered them years ago, and they have some of the best prices that I've seen on cables. Now, a little inside baseball here. There's tremendous markup on cables. There's a huge markup on cables, and we're talking a lot. I used to work for a company where I got 10% above manufacturer discount, and the cable might be $20, and you would spend $3 with the discount. So there's a big markup. Monoprice, again, in my opinion, this is not a paid advertisement, but they have some amazing prices for cables. If you have the time, check them out. If you know you're going to need some cables, be sure to check them out as far as prices go. They're, like I said, they're pretty darn good. All right. So let's take a look at layer 2. This is the data link layer. This layer is responsible for creating the data packets that will move along the network. And I kind of shouldn't have said network interface card was layer 1. I should have mentioned the connections only. So that's my bad. Okay. So we're looking at what I was thinking is this part right here was layer 1. But that was not a good explanation by me because this has got a lot more than layer 1 built in. So my bad, mea culpa, I apologize for that. So layer 2, the data link layer, this layer is responsible for creating the data packets that will move along the network. It allows the data to be sent along the physical connections, and part of its job is to also make sure the layers above it don't see any errors. So it keeps oopses away from the upper levels or the upper layers. Examples of your data link layer include switches, your network interface card, your logical topology, and your MAC address. Now I will go back, let me go back one, because within the data link layer, you also have some sublayers here, which we're not going to get into too much. But I do want to really talk very quickly about a MAC address. Every network interface card comes with a burned-in identifier. And what I like to do is explain it this way. And we'll talk about IP addresses in just a second. You have a phone number. A phone number is assigned to you by your phone provider. But you can change phone numbers. A MAC address is a unique identifying code that is given to your network interface card. It's burned into your card. You can't change it. You can't change it. But for our purposes in ITF, you can't change it. Cybersecurity, you can change it. But it's burnt in. It's like its social security number. So a MAC address is the social security number of your NIC. Okay. Then we have layer 3. This is your networking layer. Here is where we have our routing. Remember, layer 3 wants to get you from point A to point B with the least amount of hassle possible. This uses logical addressing. So with networking layer, you have things like IP addresses. IP addresses are kind of like the phone number, okay? But you also have routers at this level. Then you have the transport layer. This layer is our quality control, as it were. This layer focuses on breaking data into smaller chunks, so it can be sent easier, as well as end-to-end issues like making sure the data has reached its destination. So here we have TCP and UDP. TCP is like your mom, right? She wants to know who you're going out, to see, or who you're going to go hang out with, and call me when you get there, right? It wants to make sure things are connected. While UDP is like, you're gone. Maybe I'll see you again, maybe I won't, don't care, okay? Then we have session layer. I've already described what session layer is. That manages and terminates the data communication called sessions between networking devices. This was that shaking hands and introducing yourself. Presentation layer manages and translates information by catering to differences in the way some computer systems store and maintain their data. It formats the data for presentation for the user, and you find encryption and decryption here. And finally, our application layer is the layer closest to the user, and this allows applications to run that require a network. So for example, you see HTTP, you see POP, you see SMTP, you see Telnet. These all make other programs work. So for example, SMTP is for email. It sends the mail. HTTP, we're talking about web browsing. So it's not an application. So application layer isn't Edge, it's not Chrome, but it's the protocols, it's the rules underneath it that allow web browsing to work. It allows your email to work. It allows streaming to work. It allows these different tools that you find on the internet, on the World Wide Web, actually be able to work. Okay. All right. That actually, we kind of cut it close to the edge there, because it is 7:24 right now on my time. So we will take a break. We'll come back in our second portion. I don't think it's nearly as long as this one. We're going to talk about wireless networking. This also will be our last live stream for this week. I would love your feedback. Keep in mind, folks, that I am a teacher on spring break, and I just kind of threw some stuff together on in my office so I can do the live streams. If I get positive feedback on this, if this is something you want me to continue for the rest of the semester to help you study, I'm more than happy to do that. I can kind of snazz up the office a little bit to do these live streams a little bit better. But I want your feedback on this. Also, if you are out in the world somewhere, be sure to say hi. Here is our Discord QR symbol, so you can join our Discord channel. You can ask questions. I also have a website. Let me pull that up for you. And the website is mrfordsclass.moodlecloud.com. It's my own LMS that I'm paying for. It's Moodle is the name of the LMS. It's a very reliable open source learning management system. It's very powerful. And I have a computer maintenance class, part 1, as well as principles of infotech, which is where the ITF live. And I am more than happy to allow folks who aren't my classroom students to go in there. As you can see, I have 161 active users. I only have 71 students that I see in my school day. So over half of the folks in my Moodle site aren't even on my roll sheets. So if you're interested, by all means, please reach out to me. You can get me through Discord, or you just send me a message through YouTube or what have you. So that's going to be it from me. I'm going to finish rambling here, and we'll be back in about 10 minutes or so to pick up our second portion, which is going to be wireless networks. So see you for our next video.